geometry. Today we're going to talk about lesson 10-6. We're going to learn and apply the formula for the volume of a prism and or a cylinder. Same formula for both of them. The volume is just the base area, and then we're stacking things up, so times the height. Please write that in your notes right now. Pause the video.
Right.
Okay, welcome back. We're going to look at another aspect of this, Cavallari's principle. We have learned with surface area that if it's a right prism or a right pyramid, our surface area formulas worked. But if it was an oblique pyramid or prism, they did not. When it comes to volume, the formulas will work for both. Because if you look at this stack of CDs, if I've got 30 CDs stacked here, notice they have a particular volume, and if I push them sideways, so they're in an oblique stack, they still have the same volume. Cavallari noticed this and said, whether a cylinder is a right cylinder or an oblique cylinder, whether a prism is right or oblique, the volume remains the same. So, volume of a cylinder, just like volume of a pyramid or a prism, it's still area of the base times the height. And just a little reminder, the area of the base of a cylinder is the area of a circle, so it's pi r squared. So pi r squared for the area of the base times the height. You might want to add this formula for your area of a cylinder to your formula sheet. Pause the video and do that now. Now let's find the volume of a prism. Welcome back. Here I have a rectangular prism. Notice the base is a rectangle, and it has a height of 5 centimeters. So to find the volume of a prism, step 1 is always write your formula down. And the formula is length times width times height. Think about it as volume equals area of the base times the height. Well, a rectangle has a base area of length times width. So that's where the length and width come from. Once you've got that, you've got your formula written down with the area of the base formula times the height. Now you plug in what you know, 13 times 3 times 5, and you just multiply it out. Once you do that, you're not done, recall, until you've added your units. Now I have 13 centimeters here times centimeters here times centimeters for the height. So I have centimeters cubed. I've multiplied length, width, height 3 times. So cubic units for your volume formulas. Let's look at this again. Let's find the volume of a cube now with edge length 15 inches. And we're going to round it to the nearest tenth if we have to. We start with writing the area of the cube formula, or volume of the cube formula. Now recall, cubes, the length, width, and height are all the same. So instead of saying length times width times height, I could just say side times side times side, because they're all the same, or side cubed. Notice volume of a cube, side cubed. Think about that. Easier formula to memorize. So volume equals the side cubed. Now I plug in what I know, and I just simplify it. 15 cubed, 3,375 cubic inches. Remember to write your units. Okay? Volume of a regular hexagonal prism. Let's do this now. I know you're all going, oh no. Easy enough to do. We're going to start the same way. Volume equals area of the base, so I made a big V, times the height. Now I think, what's the formula to find the area of a hexagonal prism? So I'm going to write in there, well, it's 1/2 apothem times perimeter times the height. So that's my base area. So it's a hexagon. Let's see, how am I going to do that? I know the apothem is half of the side length, which is going to be 4.5, over the tangent of that central angle that you would find right there. And you know, to get that angle theta, we're going to do 360 divided by 2 times the number of sides, number of sides is going to be 6. So I have 360 over 2 times 6, 12. I end up with 30 degrees. So I've got the tangent of 30 right there. That's the apothem. My perimeter, well, the side length is 9 and there's 6 sides. So that's the area of my base. Height of the prism is 12, so I'll add that on too. Now it's a simple matter of calculating that out. Make sure you are in degree mode and you can follow along. I'm going to type all this in on my calculator. I'm going to do 0.5 times, and my apothem is going to go in parentheses, 4.5 divided by the tangent of 30 degrees. Close my parentheses. Now I'm going to do times. Now I'm going to have 9 times 6 because that's my perimeter. And then I need times the height of the prism. And we end up, how did we, and if you don't put your calculator in degree mode, you end up with a crazy number that doesn't make sense. So I'm going to try it again. 0.5 times 4.5 divided by the tangent of 30 times 9 times 6 for my perimeter times 12, and that makes a whole lot more sense, folks. So my area, or my volume, excuse me, and it says round to the nearest tenth, so I've got 2,525.3. Always remember units, these are feet, so we've got cubic feet, okay? Make sure you're in degree mode or you end up with some crazy negative answer like I got. That's no good. So don't panic if you see a hexagonal prism, which you will. Just follow these steps. Now, what if we have to take it a step further? I know when I was a kid, we had a pool with a liner, and it was interesting. You needed the weight of the water to hold the shape of the pool. So let's look at this swimming pool down here, 25 by 15 by 9, and let's estimate the volume of water in the pool in gallons when it's completely full. And when we're done with that, we'll see what the weight of that water is. Okay? We'll start with, okay, I know volume for a rectangular prism, base, which is length times width, times height. Plug in what I know, 25 times 15 times 9, and when we multiply that out, we'd end up with 3,375 cubic feet of water. But we want it in gallons. But they gave us a hint. They said a gallon is 0.134 cubic feet. So I know this, if I do it this way, I can say, okay, 1 gallon is 0.134 cubic feet. And then if you think about your units, I've got cubic feet in the numerator and denominator, so that'll cancel out. And I end up with 3,375 divided by 0.134. And I'm left with gallons. So I'll do that division, and I actually end up with 25186.6 gallons. So 25,186.6 gallons of water. That's why it takes a long time to fill a pool with your hose. You're better off getting the fire hydrant. Now, to find the weight of that water in pounds, we're going to do a little bit more unit conversion. I've got 25,186.6 gallons, and I want pounds. So I think of this as over 1, and I know there's 8.33 pounds per gallon. So I'll go times 8.33 pounds. LBS is the abbreviation for pounds per 1 gallon. Now notice I've got gallon in the numerator, gallon in the denominator. That'll cancel out, and I can multiply these two numbers together. Do that on your calculator. You end up with 209,804.1 pounds of water. 209,804 and 1/10 pounds of water. So it's a lot of weight that keeps those sides of the pool in. And if you've got a cement pool, it's a lot of weight pushing against the sides. So things we can do with our volume formulas. Now, volume of cylinder, let's just do one of these. Nice, straightforward. It says find the volume of the cylinder and give your answer in terms of pi and then round it to the nearest tenth. So you think volume equals, write down your formula, pi r squared times height, because volume is always area of the base times height. And the area of a circle is pi r squared. So looking at your picture, don't be fooled, don't make mistakes. Look at that and say, that's a diameter, and I need half of that to get the radius. So I'm going to put pi times 9 squared times that height. Remember, height's always perpendicular to the base. Even though that's an oblique cylinder, use the perpendicular height. And when you work it out, 9 squared is 81 times 14, 1,134, and you put the pi along. Cubic inches, never forget your units. Or if you multiply 1,134 times pi, you have 3,562 and 6/10 cubic inches. So an exact answer and an approximation, and you were asked for both. So make sure you get both. So just a little, 2 things to watch out for. Make sure you use radius instead of diameter, and make sure your height is perpendicular to your base. Now what about when you change dimensions? We know that if you're looking at surface area and you have a scale factor, surface area, the change in surface area would be that scale factor squared, because surface area is square units. Well, with volume, if you think about your volume formula, new over old, let's say we're going to multiply the radius and the height by 2/3. Our old height, our old formula would be volume equals pi times the radius squared times the height. The new one is going to be pi times some scale factor times the radius squared times, not some scale factor, 2/3 times the radius squared times 2/3 times the height, because it said we're multiplying the height and the radius. Well, to simplify that, I am going to take, and I have to square both these things. So I have pi times 2/3 squared times the radius squared times 2/3 again times the height over pi r squared times the height. Original formula cancels out, and notice what you're left with is the scale factor cubed. Volumes in cubic units. The change in the volume, if you change the dimensions, is going to be whatever that changes, that scale factor, cubed every time. In this case, 2 cubed, 2 times 2 is 4, times 2 is 8, 3 times 3 is 9, times 3 more is 27. There would be our change. We'd have this would be 8/27, the original size. Always define that change in volume, cube the scale factor. When you're looking at composites with figures finding volume, easy stuff. All you have to do is, let's look at the bottom first. This is a nice easy. Right here we've got a rectangular prism. See that there? Volume equals length times width times height. So you find that first. Now, on top of that, don't be fooled by the fact that this comes to like a point here, because the bases, that's a base, it's a triangle, and that's a base behind it. And if there's 2 bases, it's a pyramid, or a prism, excuse me. So this is a triangular, because the bases are triangles, prism. And I see that this is 8, this is 8, and this is 8, so it's actually an equilateral triangle too. So this base is an equilateral triangle, and the volume of this triangular prism is base times height, and the height would be this distance between the bases. If this is 4, it's going to be 4. Now, to find the height of this equilateral triangle, well, remember your 30, 60, 90 triangles, it's half half the hypotenuse times the square root of 3. So 4 square root of 3 is our height. So to get the area of that base area, we've got 1/2 total length 8 times height 4 square root of 3. 16 square root of 3. So now, but remember that's not the volume. That's the area of this base. Now I'm going to multiply that by the height of 4, and I end up with 64 square root of 3. So this volume, 64 square root of 3 cubic centimeters. This volume, 160 cubic centimeters. You just add them together, put them into your calculator to get a total volume of 270.9 cubic centimeters. So just find the area of each shape and put them together. In summary, find the volume of any prism. Simply area of the base times height. When dimensions change, volume's going to change by the scale factor cubed. You might just write this in your notes. Change in dimension equals k cubed, or scale factor cubed. And to find the volumes of composite figures, find each volume and just add them together. So hopefully this is going to help you, and see you in class.